and this problem is asking us to complete the standard long division algorithm for 2,478 divided by 3. Before we get into the long division algorithm, I want to start by making sure conceptually we understand what's going on when we talk about division. In this example, I have 10 slices of pizza. Now we're going to imagine that we have 3 friends that we're going to share the pizza with. I'm going to divide the pizza by simply giving 1 slice of pizza to each of my friends until all the pizza slices are gone. Now everyone has 3 slices of pizza, but I still have 1 piece left over. I'm going to divide this slice into 3 pieces and give each of the third of a slice to my friends. This means that when I had 10 slices of pizza divided between 3 friends, every friend got 3 slices and 1/3 of a slice. This example works when we're working with smaller numbers. But the problem we're given is 2,478. This is what 2,478 pizza slices look like. We could draw 3 friends and we could spend the rest of our day dragging pizza slices to each of those friends until we get a final answer. The standard long division algorithm creates an easier and more efficient way to do long division problems without having to do a lot of work. Before we get to the standard long division algorithm, I want to show one more method that I think helps conceptually understand what we're doing when we do long division. We're going to draw flowers. It's a visual representation of the division process. And we're going to start by breaking down 2,478 to better understand what that number means. I'm going to start with 2,478. Next, I'm going to look at my divisor, which is 3. That's how many groups we're splitting 2,478 into. So I'm going to draw these nice yellow dots. They're going to be the center of our flowers, but they represent the 3 groups that we're dividing our number into. Next, we're going to look at our 2,000. The problem with 2,000 is, as a 1,000, I can't split it between all 3 groups because there's only 2 of them. However, I know that every 1,000 has 10 100s in it, which means that 2,000 has 20 100s. I already have 4 100s and 400. So when I add the 20 from my 2,000, I now have 24 100s in total. I'm going to use this color to represent my hundreds place. And I'm going to draw petals, dividing them between each group until I get to 24. So I'm at 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I've divided my 24 100s evenly between all 3 of my groups. So I've taken care of my 400s, and I've also taken care of my 2,000. Next, we're going to work with our 70, which we know 70 is made up of 7 10s. I'm going to use this color to represent our 10s, and we're going to divide our 7 10s between the 3 flowers. So I have 1, 2, 3, 4, 5, 6. Now, the problem with my 7th is that if I put the 7th one here, it's not even between all the flowers. So I have almost all of my 10s taken care of, but I have 1 left over that I'm going to add to my ones place. So now between the 8 ones and my leftover 10 ones, I know I have 18 ones that I need to divide into my 3 groups. I'm going to make these leaves and write a little note to remember my leaves are my ones place. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That divided evenly, so I now have cleared out both that 8 and 10. I have 3 flowers that represent the number 2,478 divided evenly. So now I can go back through and count what I have. On each flower, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 hundreds. I have 2 tens, which is 20. And then I have 1, 2, 3, 4, 5, 6 ones. When I add these together, I get 826. This method I love because it visually represents what's actually happening when we're dividing. We're not just doing a series of steps to get a random number. We are literally dividing our dividend into the number of groups that is our divisor. However, it doesn't always make sense to spend a lot of time drawing flowers and breaking everything down, which is why the standard long division algorithm is an awesome tool. But I want you to remember this is what we're actually doing so that you can understand the process and remember the steps. All right, we have made it to the standard long division algorithm. We're going to do it on our notes, and then we're going to follow along on Delta Math as we go. So I'm always starting by looking at my divisor, and then I'm going to look at the first number and ask myself, how many times does 3 go into 2? In this case, the 2 represents 2,000, but we're just thinking about it as the number 2 right now. The answer is it doesn't. So we can leave that part blank. Over here on Delta Math, I'm clicking next to skip that spot. Because 3 doesn't go into 2, we're now going to look at the number 24. I know that 3 times 8 is 24, so I'm going to put an 8 there. I'm also going to put my 8 on Delta Math. Our next step is to multiply 3 times 8, which is 24. We're then going to subtract 24 from 24, which gives us 0, and then bring down the number 7. I'm going to type the same thing into decimals. I got 24. 24 minus 24 is 0. And then I'm bringing down my 7. Now I'm going to look at this 7, and I'm thinking, how many times does 3 go into 7? I know that 3 goes into 7 2 times because 3 times 2 is 6. I'm going to type that into Delta Math. Again, I'm going to multiply 3 times the number 2, which is 6. We're going to subtract. 7 minus 6 is 1. We're going to bring down our 8, that's in the ones place, which leaves us with the number 18. We're going to type that into our Delta Math. And for our final step, we're going to look at the number 3 again and think about how many times it goes into the number 18. I know that 3 times 6 is 18. I'm going to do the same thing here. As always, we're going to multiply 3 times the number 6, which gives us 18. When we subtract, we get 0, which means we don't have a remainder. And our final answer is 826. So over here on Delta Math, I'm going to type in my 1 and my 8 and my final answer is 0 when I subtract 18 from 18. Once you have that all filled out, you can submit. Awesome job. So as a reminder, the standard long division algorithm is an awesome tool to help you divide numbers, especially ones that are larger. But we're really thinking of it as how many times does 3 go into 2,000? If that doesn't work, how many times does 3 go into 2,400? How many times does 3 go into 70? How many times does 3 go into 8 with that leftover 10? So conceptually, it follows the same model as the flower method. However, this method is a little bit more efficient and takes less time to do. But we want to make sure we understand what we're doing when we do it.